Hello once again, it's Tubalcain, your YouTube shop teacher. Welcome back to my machine shop in my basement, and today I have yet another new project for you, and it's a tap holder designed to be used in the lathe, held in the tailstock, and in just a minute I'm going to go over to the lathe and show you how I use this in case you do not already know. The front part here is made from a commercially produced tap wrench such as this, so I have sacrificed one for the good of the cause because I have quite a selection of them in the various sizes, but this is one of the smaller sizes, and really you can't expect to hold much more than a number 8 or 10 tap in there and have the strength in your hand to be able to turn it. That's a number 8 tap. But let's step over real quickly to the Logan lathe and I'll show you how that's used in case you don't understand this. On the Logan lathe here, this is typically the way I've been tapping on the lathe for many years, all my life for that matter, and that is by supporting a T-handle tap wrench in a live center, or it could be in a spring-loaded tap holder, tap guide, and this works great, and you will continue, or I will continue to use this method for the larger taps because I have more leverage with the T-handle. But the advantage of the one I'm going to show you is that it has a lot of ability to allow you to feel the sensitivity and how hard you need to turn those tiny taps, because when you get below 8, 6, 5 and so on, it's very easy to break a tap off, especially if you have large handle and a lot of leverage. But here you're just relying on your hand on the grip and you can kind of feel that. Also, I have to continue to feed the tailstock hand wheel in to support this, so it's a two-hand operation. This will feed in and draw itself in from this removable rod. So the whole idea here is to hold that 3/8 rod in your tailstock drill chuck. This will move in and out, put a little oil on it, and simply turn it with your hand and it will draw up. And you can back it out without backing off the tailstock hand wheel. So it's a pretty handy little tool. Remember that the project here is not important, it's the operations that I'm showing you that are important that you might possibly use in some of the projects that you make in your shop. Let's go back over to the bench. There's no drawings for this, so just listen to my dimensions as I talk about them. I may leave out some, but that's the way it is when you do a project, I guess. But we have a set screw here, that's an 832, that held this in, and this is just the way it came out of my box here that I showed you a second ago, after I removed the handle. And this could be, you don't have to totally dedicate this to this tool here, but you know, if you don't throw the handle away, you still got a tap wrench. You may have to buy one of these. You really don't want to make this because it's, and I did make one when I was a high school student, but it's just, you're just better off using one that you get from the store. I'm sure all of you got plenty of these. And then this is a piece of 3/8 rod, and that's 4.5 inches long, just cold roll steel. This is the main part here, and we've got a 3/8 hole drilled all the way through, a step turned here, and a counter bore here as 1/2 inch to accommodate this. That happened to be exactly 1/2 inch or thereabout. So the hard part here, or it's not hard, but it's a little bit different, is to put these flutes on. Now you certainly could knurl this, and I have seen them knurl, but people typically have trouble with knurling, especially on a long piece like this. There's just a lot of failure or a lot of knurls that don't look pretty, so I think you're better off with this fluting operation, and there's a lot of room there for originality and creativity, so you can make that any way you want, but you need a little something there to allow you to have a grip on it. This is pretty gnarly looking here, and the reason for that is I used for my prototype just a piece of stock that I got at the scrapyard. This is part of a truck, the bow on an open bedded truck, and some of the pieces were even bent, but that's why it looks kind of funny here. I'm going to use a nice fresh piece, and I'll cut that off to length, and the length happens to be 4 inches. So you need a 4-inch piece of 1-inch diameter stock or whatever you have. It doesn't have to be 1 inch, but you'd like it large enough so you can have a grip. And that really affords a nice grip, not unlike something that you might see on a screwdriver. I call those flutes. I cut my stock to length so it's 4 inches, maybe just a hair over. It's not too critical. I have faced both ends and I am ready to drill. Now that's relatively deep hole, so I have to use extra long drill bits, and I call those aircraft length. There's a 1/4 inch for my pilot, and then this is the 3/8. Before we get started here, just a little word about what I'm using here. This is Edge Technology's product called Tool Post Drill Chuck, model 41-000, and Edge Technology is one of my sponsors, as you know. But rather than show you how this is to be set up, and it's important that it be set up on the lathe just so, I'll put a short demonstration at the very end of this video on how to do that, but I don't want to get too far away from the project here. But the beauty of this is that it is mounted right on the tool post, so I can use the carriage hand wheel to move it in and out, and even conceivably you could use power feed, but not so much on this job. So it allows great flexibility in what I call woodpecker drilling. I think they just call it peck drilling, where you drill a little bit, back it out, and so on to remove the chips and to add lubricant, especially useful for deep holes. So let's give it a try. I've got a center drill mounted in there right now. That really worked well. Now, this is the 3/8 drill here. I particularly like this keyless chuck, although if you need it a little bit tighter, this Armstrong spanner wrench works perfectly. There's holes for that. So here we go. Yeah, that tool post drill chuck sure did work nice. Now, if you have a little trouble fitting this, go back in there with a reamer. I didn't need to do that, but it fits just right, and you don't want it to be sloppy. Alright, that completes the lathe work. Now we need to go to the milling machine and put those flutes in. Now, I have to have some way to hold this and to index it. I'm going to use a hexagon collet block, 5C collet block. You could use, of course, a spin index. You could use a dividing head, just about anything you can think of, but this, of course, is the cheapest route to go, and that's a 1-inch collet. Now, I have to hold on to something so the flutes can't go the full length, and that's why I eventually will turn this down. There's another lathe operation, so I will put the flutes on to, about to where the tip of my finger is, and then later get that turned down. So I'll put this in the vise now with about 1 inch in the collet and tighten this down real nicely, and then we'll go over to the Bridgeport. Now you simply must get yourself a Bridgeport or a clone or even one from Harbor Freight or something. It really doesn't matter, but you tell your wife that you need a milling machine, not a new futon. Alright, back to the business of hand here. That's a 3/16 ball end mill, but I'm going to take that back out and use my edge finder here in a second. But I want to put 12 flutes. Well, how am I going to do that? This is a hexagon. That's 6. Well, what I'm going to do after I get the whole set up is I'm going to make one flute, then I will rotate this across one set of flats and do the next all the way around, and 6 of those. Notice also that I have a stop here, and each time I'm sliding the collet block up against this stop. That way the length of each flute will be exactly the same. So it doesn't have to be that kind of stop, but you ought to have some kind of stop. It really helps. Alright, after I've done all 6 of those with the vise catching the flats, now I will do the other 6 with the flat, this flat touching the bottom of the vise, and now the vise is catching these corners. And that also will come up against the stop. I'll do this edge finding super fast because I've covered it so many times, but once I find the edge with the edge finder, then I have to move in this direction in the y-axis, the radius of this, so that's 100 thousandths radius, and the radius of this, which is 500 thousandths, so in other words a total of 600 thousandths. And I'm looking at the digital readout, which is not in the camera frame, but I am going to zero it out and move in 600 thousandths. That's simple. And I will lock the table in the y-axis. Now I'm on the center line of the work. Again, this is a 3/16 ball end mill, and I'm going to feed in 40 thousandths. It's not very deep. So this is so simple. I'll just bring the tool down until it touches off, and I lock the quill, move it out, and I'm going to raise the knee 40 thousandths. That may not even show up in the video. Now I'm ready to cut. And now I rotate it 1/6 of a turn, bring that up against the stop, tighten the vise. Now I set the digital readout to 0, so I'm advancing my cut here until 0. It'd be nice to have a stop, but I do not. Now I'll rotate it 1/6 of a turn. Alright, that's 6 flutes so far. Now I have the other 6 to do. Now there's a little change in the setup. Now I'm going to set it, remember, on the points, or I should say a flat, on the bottom of the vise. Slide that up to the stop. Now I've lost my dimensions, both depth-wise and the center of the work-wise. Maybe that isn't apparent to you, but that changed the whole geometry really here of what I'm doing. So I have to find the edge again to locate the center, and then I also set the depth. Because as you can see right now, maybe you can't, I'm no longer in the center of the work. Or at the right depth. Okay, the work has been indexed, and I have found the edge, moved over to the center, and then found the new depth. Now I'll make one flute here, and then I won't show all of that. I'll just show you as I come back and do the 12th. So this is flute 7 that I'm milling right at the moment. I know many of you are thinking there's an awful lot of unsupported work out here, and you are right, but there's about 3 inches of cut, and it is only aluminum, and I'm not cutting very deep. If you were doing it on steel, you might need some kind of support, a tailstock or something out there. But now here is flute 12, the final one. And now I can take it out. And I'll go over to the vise and take this off with my spanner, loosen it. Well, I'm sure you all have noticed that I redecorated my collet, but you know, it wasn't my fault. I was over on the other end, so there was a place for the camera. It wasn't my fault. You know, I'm surprised I didn't hear that. But this collet appears to be dead soft, and it is made in Taiwan. Where is it? Yeah. So I need to order a new 1-inch collet, although that won't really hurt its function. I'm just a little chagrined. And now on the Atlas lathe, I'm turning this end down to approximately 15/16. The next step is to counterbore this hole, 1/2 inch diameter, about 5/8 deep, so that the shank here on this tap wrench will fit in there, and then of course a hole drilled and tapped, 10/24. And tapping the hole is the last operation. And that's an 8/32. A number 10 would work also. Got the hole tapped. Now when I put the set screw on this, I have to make sure that I straddle that hole. That's a good fit. Tighten this down. And it may be necessary at some point to grind or mill a flat on the tap wrench that fits in there if it spins, or that set screw for that matter could go into that hole that I just mentioned. Now when I prepared for this video, and yes, I do prepare for them, I ran a sample on a piece of scrap here with a 1/4 inch ball end mill, and I didn't like that at all. I went a little bit too deep probably, but I like to try different sizes. Matter of fact, that was a 5/16, which was grossly too wide and too deep. Then I went to a 1/4 and ultimately settled for 3/16, only 40 thousandths deep, and it really gives a nice grip. And we've got a good fit here. Now it is possible that you could captivate this rod by putting a flat in here and using a set screw on this end so that this won't fall out. You could make this longer or shorter, whatever you think. But that's it. Now, if you don't feel like making that, of course, you could buy one from Shars for $10 or $15. Ta-da! That, I believe, is an extrusion, and they've anodized it a pretty color, aqua. this one is captive. So I've had that for a while, but really what I've had for many years is this one that I made myself. And the reason I talk so much about flutes or knurls, this one never did have it. And this was made out of a piece of tubing that had a 1/2 inch hole in it to start with. It was a thick wall tubing, so I bored that out or drilled that out to 1/2 inch. That was a long time ago. This is half. So this was a convertible one. I really like this one. I don't know why I made this at all, other than to make a video. But the beauty of this one, and I should go back and flute this right now, but I'm not in the mood. But I could take this out, there were 2 set screws, and then you put a 1-inch button die in there and use it from this end. So this was, I thought, a pretty neat design. Tapping with one end and threading with a die from the other end. So that completes the project. I hope you liked it. There's no drawing for it. And even if you didn't like it or don't want to do it, remember there were some new operations there. Putting the flutes in and also showing you this edge technology tool post drill chuck. Now this is a set of directions that came with it. Now if you want to see me set that up, stick around and I'll have about a 5-minute demonstration on that. But if not, that completes this video. This is tubalcain saying thank you for watching and so long for now. Thank you for sticking with me. This portion of the video is devoted to showing you exactly how to mount the tool post drill chuck onto the compound so that it is done properly, it's square, and it's concentric with the spindle. I installed an extra long 1/2 inch drill bit in here just to dramatize things a little bit, and you can understand now how important it is to have the attachment right on center. And I will show you how to do that. Let's look at it from another angle. And from this view in review, you can see how important it is to have the drill bit perfectly concentric with the spindle. Also, the tool must be perfectly square and in alignment with the lathe axis or spindle. I took the attachment off the lathe and I'm at the bench, and this is how Edge Technology shipped this, and there is their website. I'll also put that in the description. Of course it was in a plastic bag, but there it is, and it came with a set of instructions here which they call the owner's manual, and that's what I'm going to go through step by step real quickly. This attachment includes a nice keyless 1/2 inch chuck, and in this little quiver here is the alignment pin, and there's a magnet in there that holds it in place so you won't lose it. This is the lug back here that goes into the lathe tool holder, the quick change tool holder. Now they recommend that you take it apart here, remove these 2 screws, like that, and using a machine vise, I'll show you how you need to attach that. Now here's the reason for doing this in a vise. There's a tendency when you tighten up set screws for the work to shift or skate just a little bit. So to prevent that, they recommend putting this in a machine vise like this, centering it where you want it, snugging it up just a little bit. I'm just barely snugging up the vise, and then tightening all 4 of these socket set screws. Snug them up real well, all 4 of them. And now I can reassemble, and it's probably easier to do it on the bench than it is mounted in the lathe. I suppose you can have your compound set at different angles. I still have it at 29 degrees, but make sure that your compound nuts or bolts here are tightened so that the compound can't swing. There's quite a bit of force against that when you're drilling with large drills. But I have to emphasize here that we have to get the tool post perfectly square with the chuck face. And I like to do that just with a parallel, and this is another tool holder here. I have several of them. Bring it up like this, and you might be able to come right against the face of the chuck depending on your chuck, but I'm using a parallel. Bring it up like that and then tighten it down. The instructions recommend that you use a dial indicator to square things up, and I was pretty darn close by the method that I used. So I'm spot on, and I've tightened it down real well. Notice that these two screws are still loose, just snug, so that this entire chuck floats around. So now I take the dowel pin out of the quiver, put it into the chuck, snug it up, and you still have the ability to raise and lower the tool holder. So you get that into about the right position. Then bring this up into the chuck or collet, and it would work even better if it was a collet. So by raising and lowering the tool block in the tool post, you can get the height that you need, and then your cross feed cranking in and out gives you the approximate location in this axis. And then the final adjustment, I'm going to bring that in a little bit farther and snug up the chuck just a little bit. And then I can tighten these down and the job is done. Now I know that seems like it took a long time and was a big effort, but it can be done pretty quickly, and tighten these up real well. And then move it back and forth and make sure that you're truly in alignment with the chuck or the collet. And take the dowel pin out, return it right away so you don't lose it. Now there's one other final thing I like to do before I start machining, and that is to zero out the crossfeed collar and the compound collar, so that should I bump these or inadvertently move them, I can find my place again without going through the whole setup. Now if you have a digital readout, zero that out, and then you are ready to use the attachment. I hope you liked this little video. Tell your friends about it. Go to the Edge Technology website, and this is tubalcain saying so long for now, and I'll see you in my next video.